To draw 6 standard views following the given model, we have to know the dimensions, height, width, and depth. Your guidelines should be much lighter so that they cannot interrupt understanding of the views. Draw a glass box which shares same width, height, and depth with the given object. The front view shows the most features or characteristics of the object. Make sure that you can determine the front view first, and then you will be able to know the dimensions, which means the width, height, and the depth. Use your straight edge to draw the two horizontal lines, which is used to determine the height. Now, starting from the most left side, we use a depth to determine the room of the left side view. Then leave 2 units between any 2 views. Next to the left side is the front view. Front view is determined by the width, which counts from the left to the right. After the front view, let's draw the right side. The right side is controlled by the depth. After the depth, we can draw the back view. The back view shares the same width as the front. After the back, let's continue to draw the horizontal lines on top of the front and on the bottom of the front. They share the same width as the front. The top and the bottom should be aligned with the front, share the same width. Both are measured by the depth from the front to the back. Inclined surface will not appear as a true size. They always show as edges or foreshortened surfaces in the orthographic projection. Let's make sure that we can mark the numbers in the isometric view so we can track where they are in the orthographic projection. Starting from the front view, because the surface B and C are parallel to the front side of the glass box, they are the true size. So we draw the B and C first. Measure the width and the height. Labeling the numbers at the corner of the surface B and C. 1 and 7 overlapping. 2 and 3 are overlapping. 5 and 6 are overlapping. One, 2, 3, 4, 5, 6, 7 should be connected in a sequence order, which shows an inclined surface edge of a surface G. Surface G is an inclined surface. 3', 4' are underneath number 3 and number 4. Surface D is foreshortened in the front view. All the other normal surfaces are perpendicular to the front side of the glass box, so we can mark them as edges in the front view. Now we finished the front, we move to the top. Starting with the surface A, because A is parallel to the top side of the glass box. Count the width and the depth to draw the surface A. The numbers in the front must be aligned to the numbers in the top vertically. The foreshortened surface G can be determined by connecting all the numbers in the sequence order. Surface D is perpendicular to the top, so the inclined surface D appears as an inclined edge in the top. All other normal surfaces are perpendicular to the top, so they appear as horizontal or the vertical edges. Now we are going to have a front and back faces of the top and the right side connected to form the 45-degree miter line. This line can be used to transfer the dumps from the top to the right side or vice versa. Because the surface E and F are parallel to the right side of the glass box, let's draw the surface E and F first. Remember, the numbers in the front and the right side should be aligned horizontally. You can use the numbers to track where they are in the right side. Let's continue to determine the rest of the numbers. All of the numbers should be connected in a sequence order so that the foreshortened surface G and D can be completed in the right side view. All the other normal surfaces are perpendicular to the right side of the glass box, so they should appear as edges in the right side view. Make sure you can mark out the surface edges in the right side view. This concludes the completion of the right side view. Since the left, back, and the bottom views are the flipped version of the three principal views completed, it becomes easier to finish the rest. The boundary of the object must be visible lines. The internal features could be hidden, so pay attention to the hidden lines.